Good morning, children. Welcome back to Ican Physics. Now in this class, we are going to see the relation between current and drift velocity. Let's enjoy the class. Relation between current and drift velocity. So let us consider a conductor XY of length L. So initially the electrons are moving randomly. So the net flow is 0 and there is no current flow. Okay. At the same time, the same conductor is connected to the external source, which gives an EMF of E, or otherwise we can say V. So that we are applying the electric field in the direction of X to Y. Then the electrons are aligned in the same direction. Okay. Then the current is defined as a rate of flow of charges through the cross-sectional area of the conductor. Now it can be taken as equation number 1. So what is Q? In the first lesson itself we know that quantization of charges. So Q equal to NE. This is equation number 2. So what is N? N is the number of free electrons. So how many number of free electrons? N number of electrons in A area of length L. Now it's taken as equation number 3. Okay. Now substitute 3 in 2. So that for instead of N, we can substitute N, A, L. So Q equal to N, A, L into E. Now it's taken as equation number 4. Okay. So now we calculate the value of numerator. Now we have to calculate the value of denominator. For that, I am going to take velocity. Okay. So what is velocity? Velocity is displacement by time. Velocity is displacement by time. Okay. Here the drift velocity is taken as a drift velocity. Okay. The displacement to the length of the conductor L. The time taken is T. The division T comes with this as multiplication. So T equal to L by VD. Now it's taken as equation number 5. Now substitute 4 and 5 in 1. Okay. So I equal to Q. So what is the value of Q? N A L into E. N A L into E. Divided by time taken. So what is the value of time taken? L by VD. Okay. Now the L by VD becomes a reciprocal. Okay. So I equal to N A L E into VD by L. Okay. VD by L. Now L getting cancelled. Okay. So I equal to N A E into velocity. Okay. Now current and drift velocity comes in the same relation. So that is the relation between current and drift velocity. Okay. அப்ப ஈஸியா எப்படியா ஞாபகம் வச்சுக்கலாம் அப்படின்னா NAE நாய், VD வீடு, நாய் வீடு. So relation between current and drift velocity is நாய் வீடு. Okay? Right. அப்ப இதே क्वेश्चन கொஞ்சம் மாத்தி கேட்டா எப்படிமா கேட்கலாம் அப்படின்னா relation between current density and drift velocity. Okay. So current density is defined as rate of flow of charges taken perpendicular to the unit area. Okay. So for instead of Q by T, we can write I. So J equal to I by A. Okay. Now what's the value of I? I is N A E into drift velocity divided by A. Now A getting cancelled. So me வீட்டுக்கு போ. Okay. So J equal to N E into drift velocity. Okay. Do you get it now? Do you any doubts? No doubt. Now in this class, we are going to see a Wheatstone's bridge. Let's enjoy the class. A Wheatstone's bridge. Let us consider 4 arms. Okay. In that 4 arms, we are connecting 4 resistances. 4 resistances, say P, Q, like that. So now give the name to the resistances. P, Q, R, S. Okay. So P, Q, R, S. Okay. Now give the name to the junction. Okay. So A, B, C, and D. Between the junction A and C, a source is connected. Okay. So from the source, the current is flowing. The current is flowing. Okay. Between the terminal B and D, okay, a galvanometer of resistance G is connected. Okay. So according to me, now this step is the important one. Why? Because I is the current flowing from the source and it comes to the terminal or it comes to the junction A. At the junction A, it splits into 2. Okay. Now it can be taken as I1 and it will be I2. Now I1 is the current, comes to B. At the junction B, it splits into 2. Okay. Now it can be taken as I3. Now it can be taken as Ig. So we are taking Ig, the current which is flowing through the galvanometer, then it is taken as Ig. Okay. Now I2 is the current comes to the junction D. Once again it is split into 2. Now it can be taken as I4. The current which is flowing this arm has to be named Ig. Already it is given the name Ig. So there is no need to give a new name or the direction of the current. Okay. Do you get it now? Do you any doubts? No doubts. Okay. Now, according to Kirchhoff's first rule, what is first rule? The algebraic sum of current meeting at a junction is 0. Okay. So, at junction B, the current I1, is flowing through the junction B. So, it is taken as plus I1. Now, I3 is the current moving away from the current. So, minus I3. Ig is the current moving away from the junction. So, minus Ig equal to 0. Now, it's taken as equation number 1. Okay. Just to see the opposite junction. At junction D. At junction D, I2 is the current moving towards the junction. So, plus I2. Ig is the current moving towards the junction. So, plus Ig. I4 is the current moving away from the junction. Sir, the moving away, moving towards just to see the arrowhead. The arrowhead moving away. That's minus I4 equal to 0. Now it's taken as equation number 2. Now we are going to take Kirchhoff's second rule. What is Kirchhoff's second rule? Algebraic sum of product of current and resistance in each part of any closed circuit is equal to algebraic sum of EMF in that closed circuit. So that I want to take a closed circuit. Okay. So what is a closed circuit? A, B, C, D, A. Okay. So A, B, C, D, A. Okay. So A ஆரம்பிச்சு A முடிஞ்சாச்சு. Okay. So product of current and resistance in the arm A to B, I1 into P. Okay. So I1 into P plus in the arm B to C, I3 into Q. Okay. I3 into Q. In the arm C to D, I am moving from C to D, but the current is flowing in the opposite direction. So that minus I4S. Okay. Now D to A, but the current is flowing from A to D in the opposite direction. So minus I to R, minus I to R equal to algebraic sum of EMF in that closed circuit. So in this closed circuit, there is no batteries involving, so that it can be taken as 0. The minus value goes to the right side as plus value. So I1P plus I3Q equal to I4S plus I2R. Now it's taken as equation number 3. Okay. Now I want to go to for next closed circuit. A, B, D, A. Okay. So A, B, D, A. Okay. So A to B, I1P. B to D, IGG. D to A, but the current is flowing in the opposite direction. So minus I to R, that is equal to 0. Now equation number 4. When the Wheatstone's bridge is said to be balanced, now when the galvanometer is in 0 deflection, or it does not give any deflection, or when the current flowing through the galvanometer is 0, then the Wheatstone's bridge is said to be balanced. Now it's taken as equation number 5. Okay, so first equation, it involves Ig. In the second equation, it involves Ig. In the fourth equation, it involves Ig. So substitute 5 in 1, 2 and 4. So when you substitute the value, so it becomes I1 minus I3 minus Ig. So what is the value of Ig? 0, equal to 0. So here 0 has no meaning. The minus I3 goes to right side as plus I3. So I1 equal to I3. Now it's taken as equation number 6. Now we can substitute here. Okay. So I2. Ig. So what is the value of Ig? 0. So plus 0. Minus I4. Minus I4 equal to 0. So once again 0 has no meaning. The minus I4 goes to right side as plus I4. So I2 equal to I4. Now equation number 7. Okay. Now we can go for fourth equation. So I1P plus Ig. So what is the value of Ig? 0 into G minus I2R equal to 0. So 0 into G, 0. So which has no meaning. The minus I2R goes to right side as plus I2R. So I1P equal to I2R. Now it's taken as equation number 8. Okay. Do you get it now? Do you any doubts? No doubts. Okay, fine. Now substitute 6 and 7 in 3. Okay. So substitute 6 and 7 in 3. Okay. So what is 3? I1P. I1P plus I3Q. So what is the value of I3? I1. I1 equal to I3. So for instead of I3, I can write I1. So I1Q equal to I4. I4 equal to I2. So for instead of I4, I can substitute I2. So I2S plus I2R. So in the both of the term, I1 is common. So I1 into P plus Q equal to, here I2 is common. So I2 into S plus R. Okay. So already we are given the name 8. So now it can be taken as equation number 9. So equation number 9 divided by 8. Okay. So what happens? I1 into P plus Q equal to I2 into S plus R. Now it's divided by. Here we are having I1P. So I1P. Here we are having I2R. I2R. So I1 getting cancelled. I2 getting cancelled. So what is the remaining? P plus Q by P equal to S plus R by R. Okay, right. So the P is common to first term and the second term. The R is common to first term and the second term. So it becomes P by P plus Q by P equal to S by R plus R by R. Okay. Now P getting cancelled. R getting cancelled. Now the plus 1 goes to the right side as minus 1. So Q by P equal to S by R plus 1 minus 1. So the plus 1 minus 1 getting cancelled. Okay. So Q by P equal to S by R. Now reciprocal the value. Okay. So when you reciprocal the value, then it becomes P by Q equal to R by S. Okay ma? Right, our dance போடலாமா? எப்படி? பாருங்க. P by Q R by S. So that is our answer. Okay. Do you get it now? Do you have any doubts? No doubts. Now in this class we are going to see the microscopic form of Ohm's law. Let's enjoy the class. So the topic is the microscopic form of Ohm's law. Okay. So let us consider a conductor of a length L. Okay. Let I be the current flowing through the conductor. Okay. So in that we can consider a small area and its small displacement is taken as dx. So that the current comes through it. Okay. Right. So what is the velocity? So the velocity is taken as a drift velocity. Okay. So what is the current? So current is taken as I. What is the number of electrons? Number of electrons is N. Number of electrons is N. Okay. Right. So what is the relation between current and drift velocity? So I equal to N A E into drift velocity. So in நம்ம லாங்குவேஜ்ல சொன்னா என்ன சொல்லலாம்னா நாய் வீடு. ஓகே. இதைத்தான் உல்டா பண்ணி என்ன பண்ண போறோம்? மைக்ரோஸ்கோபிக் ஃபார்ம் ஆஃப் ஓம்ஸ் லான்னு சொல்ல போறோம். எப்படியா? அப்படின்னா the current is defined as rate of flow of charges. Okay. அப்ப இந்த குட்டி ஏரியால போச்சுன்னா how we can represent I? So I equal to dq by dt. Now the division dt comes to this as multiplication dt. So dq equal to I into dt. Now it can be taken as equation number 1. Now it can be taken as equation number 2. Now substitute 1 in 2. So dq equal to I. So what is the value of I? NAE into drift velocity. So NAE into drift velocity into dt. Once again, the division dt comes to this as multiplication dt. அப்ப என்ன ஆகும்? So dq by dt equal to NAE into drift velocity. அப்ப dq by dt னா என்னையா? I. அவ்வளவுதான். அதே இடத்துக்கு திருப்பி வந்தாச்சு. NAE into drift velocity. ஃபர்ஸ்ட் ஈக்குவேஷன்ல என்ன சொன்னோமோ அதே தான். உல்டா பண்றோம். பண்ணா உனக்கு 5 மார்க். அவ்வளவுதான். இப்ப current density is defined as I by A. Okay. Now substitute the value for I. So J equal to NAE into drift velocity divided by A. Now A getting cancelled. Okay. Now J equal to NE into drift velocity. So what is the expression for drift velocity? So drift velocity equal to E by M into tau, where the electron is flowing in the opposite direction. Now substitute the value. Okay. So J equal to NE into drift velocity minus E by M into tau. Okay. Now E into E. It becomes E squared. So minus N E squared tau by M into E. Okay. Now this is the sign or negative sign, which gives the electrons flowing in the opposite direction. Okay. So when we are giving the electric field in the direction of x to y, so that the electrons are drifted in the opposite direction or towards the positive terminal. Okay. Now, n e squared tau by m. அப்ப அது பேர் என்னையா? அப்ப அது பேர் தான் conductivity. Okay. So, n e squared tau by m, where it flows in the opposite direction. So, J equal to. So, by taking these terms, so what we can substitute? Minus n e squared tau by m. It can be taken as sigma e. So, this is the microscopic form of Ohm's law. Now, in this class, we are going to see the resistors in series and parallel. Let's enjoy the class. So, the next topic is the resistors in series and parallel. So, first one, we are going to see the resistors in series. Okay. So, let us consider a resistor of a resistance R1 and a resistor of a resistance R2 and a resistor of a resistance R3. Okay. Is connected with a external source. Okay. So the external source gives a potential of V. Okay. Now the potential drop across the first one is V1. The potential drop across the second one is V2. The potential drop across the third one is V3. So what about the total potential? The total potential equal to V1 plus V2 plus V3. So what about the current? So current flowing through the first resistor will be same and also same. So the current flowing through each resistor will be same. So we know very well that V equal to IR. Okay. So for V1, we can modify the first case. So how we can modify the first case? V1 equal to I into R1. For the second case, V2 R2, I will be same. So V2 equal to I into R2. But what about the third case? V3 I3, then current will be same. So V3 equal to I into R3. First general case, V equal to I into RS. Okay. So why we are writing RS? Because the resistors are connected in series. Okay. Now you can add. So V1 plus V2 plus V3 equal to. So I can be taken as common. So I is taken as common. So R1 plus R2 plus R3. Now, for instead of V1 plus V2 plus V3, we can write V. Okay. So V equal to I into R1 plus R2 plus R3. Now taken as 2. Compare 1 and 2. LHS are equal. So automatically RHS are equal. So I into RS equal to I into R1 plus R2 plus R3. Now I getting cancelled. So RS equal to R1 plus R2 plus R3. Okay. So the effective resistance in series is equal to the algebraic sum of resistance of individual resistors. Okay. Do you get it now? Do you have any doubts? No doubts. Okay. So what about the second topic? Is the resistors in parallel. Okay. So a resistor of resistance R1, a resistor of resistance R2, a resistor of resistance R3. Okay. So it is connected in parallel. Okay. Okay. So when it is connected with the external source. Okay. The external source is V. Now the current I flows and comes to the junction. When it comes to the junction, it splits into 3. So in the first arm, it can be taken as I1. In the second arm, it can be taken as I2. In the third arm, it can be taken as I3. Now, here, all the terminals are connected at one single point. On the other hand, here we are having all the terminals are connected at a single point. So that the potential will be same. The potential will be same. But what about the current? Current equal to I1 plus I2 plus I3. So I1 plus I2 plus I3. Okay. So we know that V equal to IR. V equal to IR. Here we are having I1, sorry, V1, V2, V3. So that we calculated V1, V2, V3. Like that. Here we are having I1, I2, I3. Then we can calculate the value of I. So the multiplication R comes with this as division R. So V by R equal to I1. But what I said, we are going to calculate I1, I2 and I3. So for this case, I1, R1. How we can modify this formula? That is I1 equal to V by R1. For the second case, so I2 equal to V by R2. For the third case, so I3 equal to V by R3. For general case, sorry, I1. For general case, I equal to V by RP. So why we are taking RP? Because the resistors are connected in parallel. Okay. So now we can add. So when we add I1 plus I2 plus I3 equal to, in all the terms, V as common. Okay. So it is taken as common. So what about the remaining? 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So I1 plus I2 plus I3. I1 plus I2 plus I3 can be taken as I. So I equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. Now compare these two equations. I are equal. Automatically other sides are also equal. So V by RP equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. Now V getting cancelled. So that we can write 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So the effective resistance in parallel is defined as algebraic sum of reciprocal of resistance of individual resistors. Okay, do you get it now? Do you any doubts? No doubts. Now in this class we are going to see the Kirchhoff's laws. Let's enjoy the class. Kirchhoff's laws. Upper the Kirchhoff deal with V, I and R. Already we are having Ohm's law which deals with the same V, I, R. Okay. அப்ப ஏன் நமக்கு Kirchhoff's law அப்படின்னு வேணும் அப்படின்னா it deals with the complicated circuits. அப்ப Ohm's law is applicable only for simple circuit. அப்ப Kirchhoff நமக்கு என்ன பண்ணாங்க? ரெண்டு லா கொடுத்தாங்க. அதுல ஃபர்ஸ்ட் லா அப்படிங்கிறது என்னையா அப்படின்னா current law. The first law is called current law. அப்ப the first law is otherwise called current law. என்னையா current law? அப்ப algebraic sum of current meeting at a junction is 0. அவ்வளவுதான். The algebraic sum of current meeting at a junction is 0. Okay. Now I am going to consider a circuit, okay, which has different arms. Okay, like that it has 5 arms. It's arm 1, arm 2, arm 3, arm 4 and arm 5. Okay, in the arm 1 the current is moving towards the junction I1. In the arm 2, the current is moving towards the junction I2. Let us consider I3 is the current moving away from the junction in arm 3. I4 is the current moving away from the junction. Moving away from the junction in the arm 4. I5 is the current moving away from the junction. So, how we can write the equation? What we said, the algebraic sum of current meeting at a junction is 0. When the current is moving towards the junction, it has a positive value. When the current moving away from the junction, it has negative value. Now I1 is the current moving towards the junction. So it's plus I1. I2 is the current moving towards the junction. Then it is plus I2. Plus I2. Okay. I3 is the current moving away from the junction. So minus I3. I4 is the current moving away from the junction. So minus I4. I5 is the current moving away from the junction. So minus I5 equal to 0. Now the minus value goes to right side as plus value. So I1 plus I2 equal to I3 plus I4 plus I5. Here, how we can write? The sum of current entering, equal to sum of current leaving, Okay, so the first law is the conservation of charges. Okay, do you get it now? Do you have any doubts? No doubts. Now we are going to the second law. The second law is otherwise called. Voltage law. Okay. So what is voltage law? Algebraic sum of product of current and resistance in each part of any closed circuit. Is equal to algebraic sum of EMF in that closed circuit. Algebraic sum of product of current and resistance in each part of any closed circuit is equal to algebraic sum of EMF in that closed circuit. Okay, do you get it now? Do you have any doubts? Okay, no doubts. Okay, so for that I am going to construct a closed circuit. Okay, so now we are having three battery of EMF E1, E2 and E3, and its internal resistance is R1, R2 and R3. Now it's plus, minus, plus, minus, minus, plus. Okay. Here between the two, a resistor is connected. Here between the two, a resistor is connected. Okay. At the top, you are having one resistor. Okay. Then we are having three resistors are connected in between. Okay. So like that we are having a special circuit. Okay. Now we can give the name to the resistors. R1, R2, R3, R4, R5 and R6. Now give the name to the junction. Okay. So how we can give the name? The A, B, C, D, E and F. இப்போ சொல்ல போறது ரொம்ப இம்பார்ட்டன்ட். என்னையா அப்படின்னா current. So current from the battery I1. So I1 is the current flowing through R1 comes to A, just it turns. So the same current I1 is flowing through R2 and it comes to the junction B. At the junction B, it splits into two. So it may be I2. Here it may be I3. So I2 is the current comes to the junction C and it just turn. So the same I2 is the current flowing through R4 and it comes to the junction D. It is just a turn. So I2. Okay. And it comes to the junction D. At the junction E, it is splits into two. So already I have given the name I3. So here it is I4. Okay. அப்ப இப்படி போற கரண்ட்டுக்கு ஒரு பேர் கொடுத்தாச்சு. இப்படி போற கரண்ட்டுக்கு ஒரு பேர் கொடுக்கணும். ஆல்ரெடி நம்ம என்ன பண்ணியாச்சு I3 ன்னு கொடுத்தாச்சு. So no need to give a new name. Okay? Do you get it now? Do you any doubts? No doubts. So now we can go for the closed circuit. என்ன எடுத்துக்கலாம்? A, B, C, D, E, F, A. Okay? So in the A to B. A to B. I1 into R2. Product of current and resistance. B to C. B to C. There is no resistor. So there is no product of current and resistance. So we can leave it. Now C to D. I to R4. I to R4. Now we are having some internal resistance R3. So I2 into R3. Next D to E. I2 into R5. I2 into R5. E to F. I4 into R6. I4 into R6. F to A. I1 into R1. I1 into R1. Here we are having some internal resistance. So I1 into small r1. Okay. Equal to EMF in that closed circuit. So in that closed circuit, we are involving E1 and E3. So E1 plus E3. So why we are adding? Because the positive terminal is connected with the negative terminal. So it is added. Okay. Do you get it now? Do you any doubts? No doubts. Now we are going to the next closed circuit. A, B, E, F, A. A, B, E, F, A. So A to B is I1 R2 plus B to E I3 R3. And its internal resistance R2. So I3 into R2. Here I4 R6. I4 R6. Here I1 R1. I1 R1. And its internal resistance I1 small r1. Now algebraic sum of EMF in that closed circuit. So in this closed circuit, E1 and E2, but the positive and the positive are connected. Positive and the positive are connected. So that we can write E1 minus E2. Okay. Okay, do you get it now? Do you any doubts? No doubts. Now in this class, we are going to see a potentiometer. Let's enjoy the class. Okay. So the potentiometer is an instrument used for accurate measurement. Accurate measurement of current, potential difference. Okay. So அப்போ the potentiometer எப்படியா இருக்கும் அப்படின்னா it consists of 10 meter long manganese wire. 10 meter long manganese wire. Okay. It is divided into 10 segments. 10 segments. Okay. And it is fixed on the wooden board. Okay. So in that wooden board, the 10 meter long manganese wire, each of length 1 meter, is stretched like this. Okay. Now it is connected. So it may be 1. Here it may be 0. It may be 100. Here it is 101. Here it is 200. Now we can connect. Now it becomes 201. Then it becomes 300. Like that it goes. So finally it can be at 10th meter is 1000 meter. Okay. Now a scale is placed. Okay, so this is the potentiometer. Okay, so what is the principle of potentiometer? Principle of potentiometer. என்ன principle of potentiometer? What is the symbol? அப்படின்னா a straight line which is marked as A and B is the potentiometer. Okay. Now the terminal A is connected with the battery. Battery is connected with the key. Key is connected with the rheostat, and it forms the primary circuit. So battery, key, and rheostat forms the primary circuit. So in the secondary circuit, it is connected with a battery, a galvanometer, a high resistance, and a jockey. Okay. So positive, negative. Okay. Now the current is flowing through the circuit. When the jockey is touched nearby the terminal A, it shows a deflection in the left side. When it touches nearby B, it shows opposite deflection. Then only it is said to be exactly it is connected. Okay. Now the jockey is moving over the 10-meter long wire like that. So see that first one, second one, third one, like that it moves. Okay. At any of the point, it shows zero deflection. Zero deflection. Then it is said to be balanced. And the length is called a balancing length. And the length is called a balancing length. So the EMF of the cell is directly proportional to balancing length. So to take the proportional sign, we can add the constant. So EMF of the cell equal to IRL. Okay. So this is the principle of potentiometer. Suppose இதே क्वेश्चन உனக்கு 2 மார்க் क्वेश्चनல கேக்குறேன். அப்ப என்ன எழுதலாம்? இத மட்டும் எழுதினா போதும். State the principle of potentiometer. EMF of the cell is directly proportional to balancing length. அப்படின்னு எழுதினா போதும். உனக்கு 2 மார்க். இல்ல ஒரு 5 மார்க்ல explain the principle of potentiometerனா இத மட்டும் நீ எழுதினாவே போதும். You can get 5 mark. But explanationல theory part கொஞ்சம் elaborate எழுதணும். ஓகேவா? Right. Okay. So the next topic is comparison. Of EMF of two cells. Okay. So a straight wire, then it is denoted by A and B, and it is the potentiometer. Then the terminal A is connected with the battery, battery connected with the key, key connected with the rheostat. Okay. The rheostat connected with the terminal B, and it forms the primary circuit. In the secondary circuit, it consists of 1, 2, 3, 4, 5, 6. அது பேர் என்ன சொல்லலாம்? 6-way key. The 6-way key க்கு இன்னொரு பேர் என்னையா அப்படின்னா DP-DT switch. அதனால DP-DT switch, double pole, double throw switch. Okay. So from the terminal A of the potentiometer, it is connected with the middle of the DP-DT switch. So A, B, C, D. Okay. இப்போ இந்த பார்ட்டை அப்படியே எடுத்துட்டு போய் இங்க கனெக்ட் பண்ணுங்க. எப்படி? It is connected with a galvanometer. A galvanometer connected with high resistance. High resistance connected with a jockey. அப்ப galvanometer high resistance jockey வந்துருச்சு. ஒருத்த மட்டும் தான் வரல. யாரியா? Battery. Now between the terminal C1 and D1, a battery of EMF 1 is connected. It may be a primary cell like Leclanche cell. Okay. So between the terminal C2 and D2, another primary cell of EMF Psi2 is connected. Then it may be Daniel cell. Okay. So whenever we are giving the battery, we have to denote plus, minus, and the direction of current. the direction of current. Okay, so in the DP-DT switch எப்படி work பண்ணும் அப்படின்னா, at the middle there is a knob. When the knob is turned towards this side, then the Lagrange cell is connected in the circuit and the Daniel cell is excluded. Okay, இப்போ என்ன பண்ணுவீங்க? The jockey is touched nearby A. It shows a left side deflection. When it is touched nearby B, it shows a right side deflection. Then our connection is correct. When the jockey is moving along the 10 meter long manganese wire, 10 meter long manganese wire, at one particular point, it shows the zero deflection. Then and the length is called the balancing length of the first cell. அப்ப இந்த ஃபார்முலாவை உல்டா பண்ணா என்ன பண்ணலாம் அப்படின்னா psi 1 equal to IRL1. IRL1. Now the knob is turned towards the second cell. Okay. Now Daniel cell is included and the Lagrange cell is excluded. Okay. Now the jockey is touched nearby A. The galvanometer shows left side deflection. When it touches nearby B, it shows the opposite deflection. When it is moving over the 10 meter long manganese wire at one particular point, it shows zero deflection and the balancing length is measured as L2. Then the psi 2 equal to IRL2. Now it can be taken as equation number 1 and it can be taken as equation number 2. Now equation 1 divided by 2. So psi 1 by psi 2 equal to IRL1 by IRL2. R getting cancelled. So psi 1 by psi 2 equal to L1 by L2. Thus we can compare the EMF of the unknown cells. It may be Lagrange cell and a Daniel cell. Okay. Do you any doubts? No doubts. Now in this class we are going to see measurement of internal resistance of a cell by using a potentiometer. Let's enjoy the class. Okay. So the next question is the measurement of internal resistance of a cell by using potentiometer. Okay. So let us consider A and B is the potentiometer. The terminal A is connected with a battery. Battery connected with the key, a key connected with a rheostat, the rheostat connected with the terminal B. So it forms the primary circuit which is connected in series. Okay. Now label the parts, positive, negative. So it is the battery. Now it's a key and it is the rheostat. So whenever we are using the battery, we must show the direction of flow of current. Okay. So in the secondary circuit, the terminal A is connected with a battery of EMF. Psi is connected to a galvanometer. Galvanometer is connected with a high resistance. The high resistance is connected with a jockey. Okay. So it's just like the principle of potentiometer. Principle of potentiometer என்ன diagram போட்டோமோ nearly அதே தான். ஒரே ஒரு change. என்ன change அப்படின்னா a resistance is connected in parallel with the EMF of the cell. Okay. Now it is connected with another key. Now we are using two keys. So it can be taken as K1 and it can be taken as K2. The first case, K2 is open. K2 is open. The open அப்படின்னா என்ன அப்படின்னா switch off பண்ணிட்டோம்னு அர்த்தம். ஏன்னா அப்ப switch off பண்ணிட்டா no current can flow through the external resistance. Okay. அப்ப இந்த கரண்ட் எதனால மட்டும்தான் வரும்? இந்த ஃபர்ஸ்ட் பேட்டரியோட இன்டர்னல் ரெசிஸ்டன்ஸ் பிளஸ் இஎம்எஃப்னால ஃப்ளோ ஆகும். இப்பதான் நம்ம பார்த்தோம் EMF of the cell is directly proportional to balancing length. Now it can be taken as equation number 1. Okay. இப்போ நான் K2-வை நான் என்ன பண்ணிட்டேன்? க்ளோஸ் பண்ணிட்டேன். K2-வை நான் என்ன பண்ணிட்டேன்? க்ளோஸ் பண்ணிட்டேன். அப்ப ஸ்விட்ச் ஆன் பண்ணிட்டேன். இப்போ நான் ஸ்விட்ச் ஆன் பண்ணா current can flow through the external resistance. அப்ப current external resistance வழியா flow ஆனாவே it obeys the Ohm's law. So V equal to IR, then its balancing length is L2. அப்ப what is the value of I? So I equal to psi by R plus R. R plus R. Now, for instead of I, we can substitute this one. Now, V equal to psi by R plus R into R is directly proportional to L2. Now it's taken as equation number 2. Now equation 1 divided by 2. Psi by here this one psi into R by R plus R equal to L1 by L2. L1 by L2. Automatically நமக்கு ஒரு டவுட் வரும் சார் இங்கேயும் டைரக்ட்லி ப்ரொபோர்ஷனல் இங்கேயும் டைரக்ட்லி ப்ரொபோர்ஷனல் ஓகே இப்போ இந்த டைரக்ட்லி ப்ரொபோர்ஷனல் எடுத்துட்டு நான் இங்க ஒரு கான்ஸ்டன்ட் சீன்னு சேர்த்தா இங்கேயும் ப்ரொபோர்ஷனல் எடுத்துட்டு ஒரு கான்ஸ்டன்ட் சீன்னு சேர்த்தா இந்த சியும் இந்த சி என்ன ஆயிருக்கும் கேன்சல் ஆயிருக்கும் ஸோ அதனால அதை நான் டினோட் பண்ணல அவ்வளவுதான் ஓகே நவ் psi and psi getting cancelled. Now it becomes reciprocal. So when it becomes reciprocal, R plus R by R equal to L1 by L2. Now the R is common to first term and second term. So R by R plus R by R equal to L1 by L2. R getting cancelled. So it becomes 1. The plus 1 goes to right side as minus 1. So R by R equal to L1 by L2 minus 1. So now what's our topic? Internal resistance. Internal resistance. So we are going to calculate the internal resistance. So the division capital R goes to right side as multiplication. So R equal to L1 by L2 minus 1 into capital R. So by using this formula, we can calculate the internal resistance of the cell by using the potentiometer. Okay. Do you any doubts? No doubts. Now in this class, we are going to see cells in a series and cells in parallel. Let's enjoy the class. Okay. Okay, ma. So the next question is the cells in a series. So let us consider a cell of EMF 1 and another cell of EMF 2 and another cell of EMF 3 are connected in series. Okay. To the external resistance capital R. Okay. Now its internal resistance is taken as R1 and its internal resistance R2 and its internal resistance R3. Just look at the connection, how it is connected. So the positive terminal is connected with the negative. The positive terminal connected with the negative, then it is said to be cells in series. Okay. So from that we can calculate. That is the total current. Total current equal to total EMF. Total EMF divided by total resistance. Okay. So total EMF. First we have to calculate total EMF. So how we can calculate total EMF? EMF the first one, second one and the third one. So psi 1 plus psi 2 plus psi 3. Let these are all equal. Psi 1 equal to psi 2 equal to psi 3 equal to psi. So that we can write psi plus psi plus psi. Then we can say 3 psi. Suppose in case n batteries are connected or n cells are connected. So in general, the total EMF is n psi. So now it's taken as equation number 1. Now it's taken as equation number 2. Okay. Now total resistance. First we have to calculate the resistance in series of the cells. Okay. So the resistance in series is equal to R1 plus R2 plus R3. Okay. Now the internal resistance of the cells are small r1, small r2, small r3. So this is the general formula. Then we can modify for our case r1 plus r2 plus r3. So let us consider r1 equal to r2 equal to r3 equal to r. Then r plus r plus r. So it becomes 3r. Here we are connecting 3 cells so that it becomes 3R. Suppose in general, when it is n cells are connected, so it becomes nr. So these three becomes 3R. In general, it becomes nr. Now it is connected with the external resistance. So the total resistance equal to nr plus capital R. Now it can be taken as equation number 3. Okay. Now substitute 2 and 3 in 1. Okay. So what about the 1? The total current I equal to total EMF by total resistance. So the total current I equal to total EMF, that is N psi. Okay. So N psi divided by the total resistance. So what about total resistance? NR plus R. So NR plus R. So first case, when R is much less than the external resistance, then NR can be neglected. NR can be neglected. So when we neglect NR, so I equal to N times of psi by R. So this is the ideal condition to connect the cells. Why? Because when the internal resistance is much smaller, then the EMF by R is N times, so that the current will be more. So this is the ideal condition. So on the other hand, second case, R is much greater than capital R. So capital R can be neglected. So when we neglect the capital R, then I equal to N psi by NR. Now N getting cancelled. So once again, psi by R equal to I. Simply we can remember I equal to V by R. So V equal to IR. So ஒரு செல்ல இருந்து நமக்கு எவ்வளவு கிடைக்குமோ அதே தான் n number of cells connect பண்ணாலும் கிடைக்கும். எப்ப? when internal resistance is very high. So இது நமக்கு தேவை இல்லை. அப்ப எது ஐடியல் அப்படின்னா இதுதான். ஓகேவா? ஓகே, do you get it now? Do you any doubts? No doubts. Now in this class we are going to see the cells in parallel. Let's enjoy the class. So the next one is cells in parallel. So a cell of EMF 1 and a cell of EMF 2, a cell of EMF 3 are connected in parallel. Okay. To a external resistance of capital R. Okay. And its internal resistance R1, R2 and R3. Okay. So the total current equal to total EMF divided by total resistance. Okay. Now we have to calculate the total EMF. Okay. So all the cells are connected to the common terminal. So the potential drop or EMF is same. அப்ப என்ன பண்ணலாம்? psi 1 equal to psi 2 equal to psi 3 equal to psi. So the total EMF of the cell becomes psi. Okay. Now we have to calculate the resistance, total resistance. Here the internal resistance of the battery. Now the battery are connected in parallel. So what is the general formula? 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So for our case, internal resistance is taken as small r1, small r2, small r3. So the general formula can be modified. 1 by r1 plus 1 by r2 plus 1 by r3. Okay. Suppose R1 equal to R2 equal to R3 equal to R. So it becomes 1 by R plus 1 by R plus 1 by R. Now the common LCM can be taken as R. So 1 plus 1 plus 1. So it becomes 3 by R. That is equal to 1 by RP. So once again, reciprocal the value. Okay. So when you reciprocal the value, RP equal to 3 by R becomes R by 3. R by 3. Okay. So for our case, we are connecting 3 cells. So that it becomes R by 3. Suppose in general, when we are connecting n cells, then it becomes R by n. Okay. So these 3 resistors becomes R by n when it is connected with the external resistance in series. So that it becomes total resistance R by n plus R. Now you can go for LCM. So 1 into n, 1 into R, n into R, n, R. So this is the total resistance. Now it can be taken as equation number 3. Now it can be taken as equation number 2. Now substitute 2 and 3 in 1. So the total current I equal to total EMF, that is psi, divided by total resistance. What is the total resistance? R plus NR divided by N. Now it becomes reciprocal. So N psi by R plus NR is the total current. So for that we are going for 2 cases. Enna case polam appadina, when R is much smaller than capital R, small r can be neglected. So when we neglect small r, then it becomes I equal to N psi by NR. N getting cancelled. So I equal to psi by R. So once again, so V equal to IR. I equal to V by R. So when we are connecting n cells, or 50 செல்ல கூட கனெக்ட் பண்ணிக்க பேரலா, ஆனா எனக்கு ஒரு செல்ல இருந்து எவ்வளவு கரண்ட் வருமோ அதுதான் கிடைக்கும் அப்படின்னா அப்படி கனெக்ட் பண்றது வேஸ்ட். So it's not a ideal situation. Okay, so go for the another case. When R is much greater than capital R, so capital R can be neglected. அப்ப இந்த capital R அப்படிங்கறத நெக்லெக்ட் பண்ணா நமக்கு என்ன ஆகும் அப்படின்னா I equal to N psi by R. So N times அப்படிங்கிறப்ப the current is increases. அப்ப இதுதான் நமக்கு என்னது, செல்ஸ் parallel கொடுக்கும்போது நமக்கு அட்வான்டேஜ் கிடைக்கிறது. ஓகேவா? Do you get it now? Do you any doubts? No doubts.